In this video, what I'm going to do is I'm going to go over some sample problems from your Quiz 4 primarily on negations. Let's get into it.
What I'm going to do now is talk about these following problems from Quiz 4. So these are going to be 4 that are actually on the quiz, and so we've got these. So here's how they're going to appear actually on the quiz. So here I've got the italicized elements on here indicating negation. So we don't, there's an nt there, we don't park on parkways, yet we don't drive on driveways. If all of this is true, then English makes no sense. So there's all this considerate text here. All right, so that's a negation, that's going to be a squiggle. There is a negation, that's going to be a squiggle. There is a negation, that's going to be a squiggle. And the way I've got these, you notice I've got these big beefy semicolons. What that means is this. Okay, so sometimes these giant semicolons are not grammatically correct, but I'm using them to let you know, hey, look and see how much stuff you have on either side of this. If you have two things on either side of this, that means those things get grouped together. So for example, this semicolon here, how much stuff is on the left? Oh, there's this, yet this. That means those things go together in parentheses. How many things are to the right of this? Just one. So this thing's by itself. Okay, on the other hand, take a look at this one. How many things to the left of it? 4. That means there's going to be braces. So if it's just 2 elements, that would be parentheses. 3 elements would be brackets. 4 elements is going to be braces. So you're going to see braces there. And then to the right of it, only one thing. Then we've got an argument here. So this is one that we're going to have to translate and turn into a proof. And then we just have a plain old proof. All right, so this is what they're going to look like on the quiz. Now I'm going to get into showing you how to do each one of these problems. There are actually going to be ones on Quiz 4 and are indicative of the kinds of problems that you'll see on Quiz 4. All right, let's deal with the first one. And what I'm going to do is I'm going to highlight some things in here as we go to let you know that we need to do something with it. So let's look at this. So we don't, so that nt there, that's a negation. We don't park on parkways, yet that means we need to do something with this. That means and. We don't drive on driveways. Now here's one of those semicolons. That means, look at this thing right here. Okay, if you've got more than 2 things to the left of it, those 2 things are going to go together in parentheses. So basically that means this is going to be a thing. Parentheses are going to be here like this. And look to the right of it. If all this is true, then there's some more connective language. That means, hey, there's an arrow over here. If all of this is true, which means all of this stuff that came before is on the left side of an arrow, then English makes, a no sense. So how do we translate that? Basically, now I'm just going to take these pieces and turn it into formal language. So I already know that there's going to be parentheses here, and I know all of that stuff in parentheses on the left is on the left side of an arrow. What's in here? We don't park on parkways. So we don't park on parkways. Yet, that means and. We don't drive on driveways. We don't park on parkways. We don't drive on driveways. If all this is true, then English makes no sense. Let's take a look at this one. We've got, all right, there's if. If you press Control, that's a thing, comma, Alt, comma, and, that's connective language, delete. Now this is a list. Now since it's a list here, Control, Alt, and delete. What that means here is this comma here is also functioning as the same thing as this. That means there's 2 dots here. There's an and here and an and here. All right, so those would be the dots there. So if you do this and this and this on your computer, and then there's that comma there, that means the then is here, even though it's not stated. It's implied. So all this stuff is on the left side of an arrow. So if you do all this, then what? You'll open the task manager. Ooh. But then we've got this. Here's that semicolon, which means all this stuff is actually itself grouped together. So let's take a look what we got. We know that means we've got, there's 4 items here. We know we're going to have braces outside the whole thing. How do I know that? Because we're going to have brackets around this. And then since this is all ands in here, I can either put parentheses around the Control and the Alt, or the Alt and the delete. It doesn't matter which. I'm going to go ahead and do it this way. I can put parentheses around that. That's fine. Ooh, unless. So whatever follows unless goes on the left side of an arrow with a not in front of it. So this means here's what we got here. This one's a little bit complicated, but it's doable. And I'm literally telling you what it is now. So let's take a look. So whatever follows unless goes on the left side of an arrow. So let's draw an arrow. Whatever follows unless goes on the left side of an arrow. What goes on the left side of the arrow? You're not using windows. But whatever follows unless goes on the left side of an arrow. There it is, squiggle W. With the unless means there needs to be a squiggle in front of that. So that means we got 2 squiggles here. Now you might be thinking, oh, isn't that the same thing as having no squiggles? It is, but when you're translating, put it exactly as it is. Don't deduce from there, oh, that means this. I can just put W here. Nope, put it exactly like how it is. In a proof, I could tell you that you could change that. And then I said, on the right side of the arrow, we have all this stuff in braces. It's going to be a ton of stuff. Well, the first word I see is if. That means there's another arrow inside here. And up to this point, I said this is where the then is. So all of this stuff in here is on the left side of the arrow. So what's that? If you press Control and, because that's what that comma means there, and Alt, and Delete. So this is what's on the left side of an arrow. Now it's all ands. So is this dyadic? No, we have to group it together, but it doesn't matter. We can put the parentheses around the A and the D. That's perfectly fine. Or we could put the parentheses around the C and the A. I'm going to go ahead and do that, but it doesn't matter. Either one of those is fine. And then what follows on the right side of the arrow would be, if you do this and this and this, then you'll open the task manager. So hey, that's where the braces are going to end. But then, hey, if this is the left side of this arrow is not dyadic. Look, I got something over here, and something here, and something here. So actually, all that stuff on the left side of the arrow needs to be grouped together. That's what the brackets are for. And now look at this. This is dyadic. If I zoom all the way out, here, this is the left side, and this is the right side of this arrow. Okay? But then if I zoom in to this side, if I zoom into just the right side, and look at this arrow, here's the left side, here's the right. That works. And then if I zoom into the brackets, here's the left side, here's the right side. That's dyadic. And even if I zoom into these parentheses, here's the left side, here's the right side. So that's dyadic. And so thus this is a well-formed formula. So here's what it's saying, unless you're not using Windows. So yeah, it's the same thing as saying if you're using Windows, then if you press Control-Alt-Delete, you'll open the task manager, unless you're not using Windows. So that means if you're using a Mac, if you press Control-Alt-Delete, is that going to open the task manager? No. So that's what that unless you're not using Windows means. So in other words, if you are using Windows, then this stuff is true. If it's not the case that you're using Windows, then stuff is not true. So that's what this is saying here. Basically, the same thing as saying if you're using Windows, then this stuff works. Implication being, if you're not using Windows, this stuff is not going to work in this way. You can't press Control-Alt-Delete on a Mac in the same way. Or on other non-Windows devices. Try doing that on your Android phone. It's not going to happen. Okay, even if there were Control, Alt, and Delete on your keyboard, you could press all three at the same time. It's not going to open up the task manager because that's a Windows feature. Okay, now this one is not just a translation. This is a translation, and we have to do a proof for it. So let's go through. We've got one premise here, because there's the period, and then it goes straight into therefore. So what do we got? If, that's connective language. That means there's going to have to be a symbol there. A shape is a square. And there's a then it cannot be a circle. Well, let's stop there. What's premise number one then? We've got this. If a shape is a square, that means whatever follows if goes on the left side of the arrow, then it cannot be a circle. Therefore what? It is impossible. Now that the way it's rendered here is the whole thing is italicized. That means it's impossible means the following stuff can't work together. For it to be both, so impossible for both. What does that mean? It's impossible for it to be both a square and a circle. So impossible for both means if I say something like this, A and B, you can have both. If I say you can't have both, or it's impossible for both, that means this and here, nope, you can't have that. It's impossible to have both these things. That's what this would mean here. So if I were to cover the squiggle, yeah, both of these. What does this mean? Not both. You can't have both. So what this is saying is, what we're solving for is, you can't have something that's both a square and a circle. So we've got this assumption. We want to get this. In fact, later on in the semester, you're going to learn a move that allows you to switch between these in one move. It might not be obvious yet that it's the case. But yeah, if you've got a shape that it's not a circle, then it's the case that, you can't have something that's both a square and a circle. Do we have an arrow, not in parentheses? Oh, very much so. Do we have a left side match? Nope. Do we have a right side contrary? Do we have a C somewhere? Do we have either an S that would be a left side match? Do we have a C that would be a right side contrary? Nope. Is there a dot we can break apart? Nope. Can we do an and in? Not even if we wanted to. Can we do a double negation? We could, and get all of this with a set of double squiggles in front of it. That leads us nowhere. Is our goal an arrow? Nope. So what do? Indirect proof. What do we do in that situation? We provisionally assume the contrary of our goal, and then we seek out a contradiction. So what would be the contrary of squiggle S and C? If I'm saying not S and C, what would be the opposite of that? It would just be plain old S and C. Now you could say it would be, well actually it would be squiggle squiggle S dot C, and then you could do a double negation on that, and then you would have this. That's fine. Okay, when you're translate exactly as is. But I think here when we're dealing with direct opposites, I think that's obvious there. I think that's intuitive. So I'm going to say here's our provisional assumption for an indirect proof. So We got our provisional assumption. What are we after? What do we want to get now? Any contradiction. Any two contraries that we can slap together with an and in. So that's the mission right now. That's the side quest. So now, go back to the top of the list. Arrow out. Nope. Modus tollens? Nope. And out. Yeah, that's a new dot there. Unburdened by parentheses. What's it do? It breaks down into these two things. We get S and we get C. And out on line 2. And actually we have two routes that we can go here and we win. It doesn't matter. Now look, we have a left side match and we actually have a right side contrary. Either route that you go will solve this problem. However, for the sake of being consistent, you can do it the other way if you want to see how it works. For the sake of being consistent, I'm going to follow this list. Because this list, until we get later on, this list as it is here, will always yield the most efficient results. Here it ends up being just as efficient, whether you do a modus ponens or an arrow out in the next line, or a modus tollens. It's kind of a choice. If you're feeling dangerous, you can do it the other way. But here I'm going to be consistent and say, if you can do this thing, go ahead and do it. So do we have a left side match? Yes. What does that get us? Squiggle C. And if you did the modus tollens instead, you would get a squiggle S, in which case you'd have S and squiggle S. But as it is for us now, doing it this way, we already got that C and squiggle C. How do we get this here? Arrow out. 1 and 3. Which means, by the way, since you can go another route, if you did the other route, it'd be just as correct. There's not bonus points for doing it this way. It's just as efficient, takes just as many steps. If it's a matter of preference for you, that's fine. And the way logic works is if you can do it, it's fine. But I'm going to do it this way. So yeah, we got squiggle C, arrow out 1 and 3. There are my contraries right there. But just to be consistent, can I do an arrow out? I did it. Can I do a modus tollens? I can, but I don't need to because I've already got the pieces that I need. And you can see that, so maybe you might get the squiggle S out, in which case you'll have two sets of contraries. Take your pick. But I know what I need to build here. It's right here, and I knew this when I started this indirect proof. There it is. That's what I sought. I was seeking this. Here it is. So let's go ahead and stick it together. C and squiggle C. And in. Oh, they're right next to each other. Very convenient. 4 and 5. Side quest complete. I provisionally assumed the opposite of my goal, and I got a set of contraries, which a set of contraries is a contradiction. So what I'm saying here is, if this is true, it leads to nonsense, because contradictions are stupid. Which means, if this is true, if this leads to this, then its opposite must be true. Then this is really true. So what I do is I zoom out, and I say, yep, we've proven this. Albeit indirectly. And what I mean by indirectly is if the opposite were true, it would lead to nonsense. So we can say indirect proof, where do we start that quest? Line 2. Where did it stop? Line 6. Let's take a look at this final one from the Quiz 4 prep here. So here's what we got. What this means is, and it's when it's laid out like this, as it's been laid out in Quiz 3, that's the first assumption, that's the second assumption, and then this thing here, that sideways T, means here's what you're looking for, this. So let's write it out. Line 1, squiggle L, arrow M. Line 2, squiggle L, arrow squiggle M. These are our two assumptions. And what are we after? Just plain old L. Now, also, this is another one that later on in the semester, we'll actually be able to finish this in step 3. There's a move that allows you to do this. And you might see it. Like, look, if squiggle L is leading to M, but squiggle L is also leading to not M, then squiggle L is itself ridiculous. There's an indirect proof hiding in here already. Like, listen, squiggle L is stupid because it leads to both M and not M, and those are opposites, so then L must be true. That's what's going on here. So we already know that it's provable. Let's make it work, though. Let's actually prove it. So first of all, do we have arrows, not in parentheses? Yep. Here and here. Any left side matches, any squiggle L, not to be found. Modus tollens, is there a squiggle M by itself? There is one here, obviously. Is there a squiggle M by itself? No. Is there just a vanilla M by itself? No. Do we have a dot we can slice in half? No. Can we build with an and? We can, but that gets something way more complicated than what we need. Double negation, again, it is an option, but it doesn't lead anywhere. Is our goal an arrow? Nope. So what are we going to do? Provisionally assume the opposite of our goal and get a contradiction. So let's do that in step 3. What would be the contrary of L? Squiggle L. You can see that's already going to be convenient. So provisional assumption. And what are we after? Any contradiction. It doesn't matter what we get. So now, can we do an arrow out? Yeah, 2 sets. Let's go ahead and do the work there. We get immediately M, arrow out, 1 and 3, and also squiggle M, arrow out, 2 and 3. And hopefully you can see, like, right there, that's exactly what we need for this. There are contraries right there. To be consistent, can I do another arrow out? I did them all. Modus tollens, can I do those? Yeah, but you're just going to get the same stuff you already have. Well, I've got an M here. That's the opposite of this. Then I can get squiggle M, but you've already got it, so it's definitely not needed. You could do it. It wouldn't be wrong, but it'd be redundant. So I wouldn't take points off for it, but we can be done much more efficiently here. There are the pieces. Let's go ahead and build it with an and in, because remember, indirect proof always ends with an and in. So I can say M dot squiggle M. Then I just say, yep, I did that. I stuck them together. Where'd I get the pieces? 4 and 5. So that means squiggle L is stupid, because if you get it, it leads to nonsense like this. M's are also not M's. Which means if that's the case, we can zoom out and say, if this leads to nonsense, then its contrary, L, is a thing, albeit we proved it indirectly. The game started in 3. We finished in line 6.
So that concludes this video on a couple of sample problems from quiz 4 on negations, and this also concludes the module on negations. What I'm going to start doing in the next series of videos is talking about biconditionals. See you next time.